Hi, I'm here today to talk about finding the center of mass of this shape, which is a half cylinder located on the xy plane of constant radius r. We see here that it is centered on the y-axis with the entire diameter running across x, so that's the same radius on each side, and because of that symmetry, we can see that x will change uniformly as y changes, meaning that our center of mass in the x is going to be 0. So we can look for our center of mass only in the y direction. And the general center of mass formula is listed here as 1 over total mass times surface density, and that's an integral over your x, y, or z direction of some small changes in area labeled here as dA. And up here, I've shown that surface density is total mass over 1/2 pi r squared, which comes from the formula for a half circle. And over here, I've shown how x and y can be changed from their Cartesian x's and y's into things in terms of radius and theta, which we will use for polar coordinates. So first, we set our equation up and get everything into its proper polar terms, where we have r squared sine theta dr d theta. And I want to look at our integrand here for a moment because we have to find these bounds of integration, and we'll find them from our diagram up here, where we know our fixed radius is just 0 to r, starting at the origin. And we know our theta value can only run from 0 over to pi. So that's how we've chosen these bounds of integration. And after that, we will do a pretty straightforward integration where we will choose to do the dr bit first, for which we get r cubed over 3 as the integral of this r squared after we evaluate it from 0 to r. And then we will take the integral of the theta piece, for which we get the integral of sine is negative cosine, and you can see that here. And negative cosine of pi becomes 1 minus the negative cosine of 1, so this becomes 1 plus 1, and we just multiply by 2 here. So now we have what seems to be a little bit of a mess here, but we can clean that up. I can show that these terms will cancel, leading to a final product of 4/3 radius over pi as the location of our center of mass. And that is integrating for center of mass in polar coordinates.